So my talk is based on a review article I've been asked to write for Mathematical Biosciences. And it's based on non-human animals, but my hope is that there will be enough of an analogy that the models can be adapted and extended for humans. And you could either encourage that hope or totally extinguish it, or somewhere in between. Okay, so a winner effect is a higher probability of winning after winning or of losing after losing. And such effects were first studied in the context of linear or near-linear dominance hierarchies. Those are ones that have no or very few intransitive triads. And how those hierarchies form is controversial, but there's no doubt that they do. They've been widely observed in many species. And regardless of how they form, strength or fighting ability, otherwise known as resource holding potential or RHP, is never a perfectly reliable predictor of the outcome of a contest. So a hierarchy like that can persist only if sometimes a stronger animal considers itself subordinate to a weaker animal instead of trying to reverse the asymmetry at a subsequent encounter. And it's reasonable to ask why. And winner and loser effects are a possible answer. It may be that after winning, a weaker animal revises its perception of its RHP upwards, and maybe a stronger animal that loses revises it downwards, and now it lies below an evolutionarily stable threshold for aggression, whereas previously it lay above, and that provoked the fight. And consistent with this idea, for example, are some experiments in the common crayfish by Momohara et al. They found that those having won a contest against a larger opponent won about 70% of subsequent contests with larger naive animals, those who haven't had a contest, despite a physical disadvantage. And losers of contests won only about 6% of subsequent contests with smaller naive opponents, despite their physical advantage. And this is my one excuse to get a couple of color pictures in two different views of the common crayfish, and here's a third view that's more familiar to a lot of people in Tallahassee. So models of winner and loser effects fall into two broad categories, and rather unimaginatively I'm going to call them type 1 and type 2. Type 1 models explore the implications for dominant structure of winner and loser effects, assuming their existence at the outset. And there are lots of these models, and they've demonstrated without a shadow of a doubt that dominance hierarchies can arise through winner and loser effects alone. Whether they do or not is another matter, and it's controversial, and I'm not so interested in that, because if you accept that this is what happens, then another question arises. Why should winner and loser effects evolve in the first place? And that's the question that I want to explore. What factors favor the evolution of winner and loser effects to begin with? And such models regard winner and loser effects as the outcome of a strategic response, so they are game theoretic. So my universe of discourse is in the dark shaded disk on the right. Type 2 models are strategic models, but not every strategic model is a type 2 model. And trivially, because it may be dealing with something else entirely, that's the white space. But it's also possible, and this is the light shading, a strategic model could be a type 1 model. For example, Rufus Johnston, Lee Dugatkin have a model where they explore the effects of winner and loser effects on coalition formation. The model's strategic because you have to decide whether to join a coalition or not, but you assume the existence of winner and loser effects at the outset, so you can't use that kind of model to see why they should evolve. So these are the models that I'm reviewing, and I've discovered that there aren't very many of them. I counted precisely 4, and they're based on 3 different mechanisms. And first of all, winning or losing can raise or lower self-perception of RHP, thus raising or lowering contest motivation. And there are 2 of these models, and I'm going to call the first one the self-perception model, and the second one the age-dependent model, because it adds the effect of age to the model, but the mechanism is the same, revised self-perception of RHP. Another possibility is that winner and loser effects could be a consequence of a convention. So a convention is a rule for resolving a dispute over a resource that evokes some arbitrary asymmetry or focal point to avoid the costs of fighting. An example of an asymmetry could be whoever guessed the resource first gets to keep it. It may be that the weaker animal got there first, so sometimes a stronger animal is giving the resource away to a weaker animal, but it's avoiding the costs of fighting. Example of a focal point would be a landmark, could be used as a territory boundary. It may be the stronger animal could have pushed for a bit bigger territory if it had fought, but it avoids the cost of fighting by observing the convention. And the convention model in this case is based on the historical asymmetry of winning or of having won or lost. The third possibility is the winner effect can arise even if the animal experiencing it does not change its behavior. It may become more likely to win because its opponent revises its propensity to escalate, either in response to a victory display or another social cue, or after eavesdropping on the protagonist's prior win. And there's one model here, and I'm going to call it social eavesdropping model because it's the only one of the possibilities that's been modeled yet. And there are other mechanisms, but they haven't been yet modeled. So I'm starting with the self-perception model, and it's a game, and to have a game, there are 4 things you need. You need a set of players to interact, you need strategies to interact with, and that implies an information structure. You need a reward or fitness function that gives the fitness to every conceivable strategy combination. And then finally, you need a solution concept, and that's always evolutionarily stable strategy where I am concerned. So who are the players? These are animals drawn at random from a large population, and they vary in RHP. And I'm assuming that they're drawn from a beta distribution. The weakest is 0, the strongest is 1, the distribution is symmetric, so the mean is always a half, but the variance is arbitrary. And what strategies can they use? Well, strategies are 3-dimensional vectors. The first component is initial self-perception of strength. The second component is self-perception of strength after winning. The third component is self-perception of strength after losing. I'm assuming the animals don't know their own strength or the opponent's strength, but they do know the distribution. They know what the variance of the distribution is. And if they, the reward depends on 3 parameters. The first parameter is the variance of the distribution. The second parameter is B, and this is essentially the fitness to a beta individual. Without loss of generality, I'm saying that the alpha individual has fitness 1, the gamma individual has fitness 0, and there's something I've forgotten to tell you. I'm assuming that this population is subdivided into triads. They interact in threesomes, not because lots of populations do that, but because it's convenient theoretically. It's the smallest group size in which you can have a network effect. And every animal engages in 2 contests with each other individual in its group, and those contests can be in any order. So you could fight 2 experienced animals, you could fight 2 naive animals, you could fight 1 of each. The fitnesses are 1, B, and 0 if there's a dominance hierarchy. The other possibility is an intransitive triad, and then I take the total fitness 1 plus B and divide it by 3, and everybody gets that. So those are the rewards because they are contesting dominance. And the greater their perception of their strength, the more likely they are to win. The probability of winning is proportional to the difference in perceptions. And the cost, the third parameter, R, is marginal cost. If you overestimate your strength, you pay a cost, and the more you overestimate it, the bigger the cost you pay. And with those 3 parameters, I'm able to figure out the evolutionary stable strategy, and I'm showing it here as a function of variance. When this diagram first appeared on my computer screen, my daughters were in the low single digits, and they thought I was trying to explain the evolution of whales. And they were rather disappointed, I think, when they discovered that I wasn't. But anyway, this shows the orange line is the initial self-perception. The green line is after a win, the red line is after a loss, and the difference, W is the winner effect, the difference between the two, L is the loser effect. And you can see that winner effect increases with variance. Loser effect essentially also increases with variance, because by the time you get over to the right-hand side, the variance is too extreme to be relevant in practice. That's as a function of variance, and then as a function of the other two parameters, I have R on the right-hand side, B on the vertical axis, and you can see there are three things that can happen. You can have no winner or loser effect. That's the lighter shaded region. And then down near the bottom, you can either have both a winner or a loser effect. That's over towards the right. And then towards the left, region 2, you can have a loser effect without a winner effect. But you can't have a winner effect without a loser effect. This is what the model predicted. On now to the convention model. And the assumptions of that, first of all, there's zero variance in the convention model. If I had zero variance, I wouldn't get a winner or a loser effect. That's the very left-hand side. That's the whale's nose. And individuals engage in repeated pairwise conflicts in this model, whereas I was just assuming that within a triad, round-robin competition decided the outcome. They're assuming, this model is by Sander van Doorn, Eert Engeveld, Franjo Weissing. They're assuming that individuals have lots of encounters and they remember the previous encounter with the current opponent, and only that, or they ignore other information. So I may have a fight with you and another fight with somebody else, and then I come back and I fight you again, and I remember what happened last time, and I've kind of clean forget all the other encounters that happened in between. And animals condition behavior on whether or how they won or lost. Two hawks or two doves are equally likely to win, and a hawk always beats a dove. And with those assumptions, players can distinguish 6 situations, forming 3 pairs of complementary winner-loser situations. So a strategy is a 6-dimensional vector. PI is a probability of aggression in situation I, or SI, and S1 is having won through physical fighting, S2 is losing that way, S3 and S4 having won or lost through threat and withdrawal alone, and finally having won or lost through ritualized display. Essentially a coin toss decides the winner in the last possibility. And this is a very numerical paper, so I've plucked a typical dominance convention solution out of their paper, and as you can see, the 3 ones tell you that the probability of aggression, if you've won, is always 1, and the probability of non-aggression is 0 if you've won after if you've lost after a physical fight, but it's positive if you have lost because you withdrew or because you lost a coin toss. And there's various points one can make about this. First of all, it's not quite a convention in the usual sense, because with a true convention, there's never any fighting. Here there's obviously some. Second point, only some winners have a higher probability of winning again. Others experience no winner effect at all. If you're in situation 3, then probability 0.68, you go back to that state, and you can't win, you can't increase your probability of winning, which is 0.84 in that state, unless you engage in a physical contest. There's only 0.16 probability of going to that state. So it turns out you're 4 times as likely to experience no winner effect as to experience a winner effect. And then if you do experience a winner effect, you can't experience it again until you've lost in the meantime. Because prior experiences are always assessed with respect to the same opponent, a winner effect implies a loser effect and vice versa. You have both or you have neither. And fighting is assumed very costly in this model. So it's consistent with the self-perception model for large R, despite having 0 variance. And you can see that if you go back to here, high cost is over here, and in this model you either have no winner or loser effect or you have both. But it's not predicting a winner effect without a loser effect. So I've built a little bit of a table with these 2 models on it. The third model is very like the first one in terms of its properties, and it's simply confirms that the logic of a winner effect without the winner changing its behavior is sound. And the age-dependent model, well, I've added that to the table, but I'll skip it. So theoretical predictions versus empirical evidence. What do we have? The self-perception model predicts that a loser effect can exist alone or coexist with a winner effect, but a winner effect cannot exist without a loser effect. And that's consistent with both the convention and age-dependent models, despite they're not predicting a winner effect without a loser effect. Now, you could say that you can't tell the difference between a winner effect without a loser effect and a winner effect with a very weak loser effect. But the only time you get that is when the variance is extremely high. I mean, it's a bimodal distribution with a spike at each end. It's very unrealistic. And the other possibility is in Fawcett and Johnson's model, the age-dependent model. You can get it at very old ages, but too old to really apply. So these results were actually very well upheld by numerous experiments over several decades until quite recently. Marlène Goubot and Marie de Quinière have done some experiments in wasps, and they found evidence for a winner effect without a loser effect. And no existing model predicts that. And there's no evidence to date that the contests are influenced by RHP at all, suggesting that self-perceptions aren't relevant. And there's also no evidence that has anything to do with a network effect or observing a convention. So conclusion is that, on the one hand, we need a new model. And in particular, they have argued that it's differences in subjective resource value that explain their results. So basically, these wasps, they need a host to lay their eggs in. And until they have a host, they can't really use them. This is what to keep them on the shelf. And then if they win a fight over a resource, they sort of flick the switch. And then from that point onwards, there's not much they can do with the eggs except lay them. And then if another animal comes along and challenges them, they're sort of highly motivated to win. So verbally, it seems quite a sound argument. I think I'm going to probably skip to the very last slide. One ought to have some, what happened here? Why didn't I go to the very end? I'm not sure. Okay, my conclusions are embarrassingly feeble, I have to admit. Basically, the evolution winner and loser effects has received remarkably little attention from theoreticians, and to some extent, that state of affairs is not surprising. The requisite mathematical analysis is frequently very complicated, and existing models have been well supported by empirical literature for several decades. Nevertheless, recent experiments and field studies have reported outcomes that existing models are not designed to predict. In particular, theory doesn't address how winner and loser effects interact with residency effects and variation in subjective resource model. We need new subjective resource value. We need newer models for that. And motivation, well, one thing I skipped is that, for example, winner and loser effects can be context dependent. For example, in California mice, there's a winner effect experienced at home, but not away from home. Apparently the testosterone rises in both situations, but it's only when the animal wins at home that the brain circuits for increased motivation are actually activated. So it's very highly context dependent. So my overall conclusion is that there was perhaps good reason not to worry about how well the models were doing for quite a few years until quite recently, and now we really have to start building some new ones. And I hope to have got further with this, but I just ran out of time over the summer. Ran out of time now as well.
Thank you very much. Is this on? Yeah. Thank you very much. Very inspiring. I have just a short question. Do you think your results easily generalize to groups, or do they work for individuals only at the moment?
I think individuals only at the moment, but obviously that's a hope that I could generalize it to groups as well. Yeah.
Yeah. Yeah, so I think this is really interesting with the winner and the loser effects, and it's actually something I've been looking at recently with the parakeets. And what I've been finding is that there's a rank-dependent loser effect. So losing to a higher-ranked individual causes a really strong loser effect. But losing to a lower-ranked individual has no effect on that target's behavior going forward.
Okay.
And so I think it's really interesting to think about that in terms of modeling, because that's then an effect on the very local behavior that's, you know, dependent on this emergent property of rank, and kind of the feedbacks between the two would be really
Right.
interesting to,
Yeah.
to look at.
I think there's still a lot of scope for what I called type 1 models, but it's just that the original idea of trying to show that winner and loser effects can generate a linear dominance hierarchy, that's been done to death. I've kind of got tired of it, but there are obviously other things that could be explored in that context as well.
That's a fantastic thing. I really want to talk to you about that too, because that's the opposite of course, the biggest winner-loser effect in a lot of primatology is the Hemmelreich models. It's the exact opposite of her assumption is what you found, which is great, because I just wanted to say another thing about the Hemmelreich models. That Bernard Thierry was trying to get me to improve on them, and he told me the second point here, he has decades of data about this, so that there are different motivations in the macaques, that they actually seem to show different dominance hierarchies depending on what the current thing that's to be fought over. So I just wanted to make a very quick comment that I can help you with some of that data.
Oh, that would be great.
searching, so.
Yeah.